Alright, we're going to do related rates. So let's just recall implicit differentiation. So if you differentiate this, and it's 2x, and you're differentiating this x term with respect to x. So that is secretly there beside it. You just don't write it because this is essentially 1. And then if you differentiate this, 3y squared, and now we've differentiated a term that's got a y in it with respect to x. So we do have to put that beside it, but we have shortcutted it that it looks like y prime. And then differentiating a constant, we get 0. Okay, so I'm going to work to isolate this piece. So 3y squared y prime equals negative 2x. I've moved that over. And now I can divide. Okay, so that's the gist of what we're going to do today. Okay, suppose that x and y are connected by this statement. You are given that the change of x with respect to time equals 2 when x equals 1. Find the change of y with respect to the change of time. So now, instead of differentiating with respect to x, we're differentiating with respect to time. So the change of x with respect to the change in time. So that's what this is all talking about. Okay, so I'm going to take this, we're going to implicitly differentiate it. Okay, so this is going to be 8x, and we have now differentiated that x with respect to t, and the y term is 9y squared, and we're differentiating the y with respect to time equals 0. Okay, now we're going to fill in what we are given. So you are given the change of x over the change of time is 2 when x equals 1. So we've plugged in that. 9y squared, I'm going to have to figure that out. And the change of y over t, I want to know. Okay, so this y I can figure out because I know x is 1. So 4 times 1 squared. Okay, so this is 4. So if I subtract 4, divide by 3, and cube root, I get y is 2. Okay, so now I know that. Don't forget we still have to square that. Okay, so I differentiated it, and now I've plugged in everything I know. So 8 times 2 is 16. 9 times 4 is 36. So I'm going to move the 16 over. So the change of y with respect to time is negative 16 over 36. Or you can write it as a decimal as well. So negative 16. Okay, so y is changing with respect to time. Okay, a snowball is melting, so the volume is decreasing at a rate 1 cubic centimeter per minute. What rate is the radius decreasing when the radius is exactly 5 centimeters? Okay, so we are going to differentiate this. So the change of volume with respect to time, okay, that's just like me differentiating x, like there's just a 1, right? It's just a 1, and then you still have to always do the implicit piece. Okay, so let's think about this. This is going to be the coefficient times the exponent. So what is 4/3 pi times a 3? You can see the 3's would cancel, and I would just get 4 pi. And then r, and then down. But I have now differentiated something with respect to r, so I still have to times it by the implicit piece, change of radius with respect to time. Okay, so now we know volume is decreasing, so this is the change in volume with respect to time. I'm going to write a -1 because it's decreasing, and 4 pi when the radius is precisely 5, and what is the change of the radius. Okay, so -1 divided by, so this is obviously a 25, and then this is a 4, so this, I'm going to make it as 100 pi. See, is that okay if I did that? That's 100 pi. So, -1 divided by 100 pi. Just doing that. So, negative that's the change in your radius. It is decreasing, obviously, at a very small rate. Okay. A man walks 1.5 meters per second easterly direction, and a woman is walking in a northerly direction. Okay, so the man is going east, and a woman is going north. Okay, so the man is going at a rate of 1.5, and a woman is going at a rate of 2. What is the rate that the distance between them is increasing exactly 1 minute later? So let's talk about 1 minute later, their actual distance. In 1 minute, okay, think about this. This is in seconds right now. So if you go 1.5 meters per second, so you have to times that by 60, then the man is located 90 meters away. And the woman is going to be 120 meters away. And we can use Pythagorean theorem, so 90 squared plus 120 squared, and then square root it. And we get 150. Okay, so that's what we know. We know the rate that those two were moving, and we know exactly their distances at 1 minute. Okay, so here's the equation. A squared plus b squared equals c squared. Okay, that's the equation I know about their distances. So I'm going to derive it. So 2a times the change of a with respect to time plus 2b times the change of b with respect to time equals 2c times the change of c with respect to time. Okay, so now I've derived it, and I'm going to fill in what I know. Okay, so let's label. What do you want to do here? A is the man, B is the woman, and C is the hypotenuse. Okay, so 2 times the A is 90 then, and that is changing at that pace. plus 2 times 120, and the change of the pace is 2, equals 2 times 150 times what we want to know. We want to know how is this hypotenuse changing. So, right, like as you keep going out, your hypotenuse is just going to keep getting bigger and bigger as well. Okay, so let's get some numbers here. So this is 270, 480, 300, so 750. So 750 divided by 300, and we get 2.5 meters per second is the change of the hypotenuse with respect to time, or in other words, their distance apart from each other. That's the rate it's changing at precisely 1 minute of time. Okay, next question. A ladder is slipping away from the side of a building. The ladder is 1.7 meters long. It's slipping it away at a rate of, what does it say, 1 meter? 1 meter per minute. At what rate is the top of the ladder sliding down when it is exactly 0.8 meters away from the building? Okay, so here's our wall and our floor. So let's draw, that's my ladder. The ladder is 1.7 meters long. It's slipping away. It's slipping away. At what rate is the top of the ladder sliding down? We want to know that rate when it is at a distance of 0.8 meters. Okay, so let's figure out our triangle. So when our ladder is 0.8 meters away, what is the distance from the floor to the top? So Pythagorean theorem. Alright, so what do we get? 1.5. Okay, so let's do our a squared plus b squared equals c squared. And derive. So 2a, change a with respect to time, plus 2b, and the change of b with respect to time, 2c times the change of c with respect to time. Okay, I'm going to call this my a side and my b side, and obviously that's your c. Okay, so 2 times the a distance is 0.8. A was changing at a rate of 1, plus 2 times the distance of b times b, changing with respect to time, that's what we want to know, equals 2c. And what is the rate that c is changing with respect to time? Well, that would be 0. Okay, the ladder distance is not changing, right? That side would never be changing. Okay, so 2 times 0.8 is 1.6 plus 3. This whole side will equal 0. So I'm going to move that over, and then we're going to divide by 3. So it ends up being, so negative 1.6 divided by 3 is negative 0.533 meters per minute. So that is how that is changing. It's going down. Okay, next question. A cone-shaped bin is filling up with grain. Not sure. Could be upside, downside. Okay, It's filling up the rate, 7 meters cubed per minute. The height of the bin is 10 meters. The radius is 4. Find the rate at which the height is increasing when the cone is filled to a height of 5. Okay, so first of all, we need to know the volume. So that's the volume of a cone. Let's talk about the height is 10, the radius is 4. Okay, so let's talk about a relationship here. The height, so 10 is what compared to 4? So 10 divided by 4. So the height is 2.5 times as big as the radius. And the radius is, so just take this divided by that, so 4 divided by 10. So it's 0.4 as big as the height. Okay, so we're going to be inputting something into this equation. Okay, so let's think about what we're doing. We want to find the height at which the height is increasing. So what we want to do is we want to know the change of, that's our goal, right? So we want to know the rate of the height increasing. So I want to leave h's in this equation. So therefore, if I'm leaving h's in, I'm going to replace the r. I'm going to replace the r with an h. Okay, so volume equals 1/3 pi 0.4h squared times another h. So I haven't derived anything, I'm still working with just the volume. Okay, so 0.4 squared is 0.16, and then this would be an h squared now, and then times another h. So I'm going to 0.16 over 3, so I'm going to put those two numbers together, pi, and h cubed now at the very end. Okay, so now I'm going to derive it. So the change of volume with respect to time equals, okay, now don't forget how to derive. This is just all a constant exponent. So this times this, so that's what I'm doing. I'm doing k times n. That will cancel and I'll get 0.16 pi h, and then down the coefficient. And then don't forget your implicit piece, you have to change the change of h with respect to time. Okay, so we know this rate. Volume is changing at that rate. When the height is 5, and we want to know how the height was changing. Okay, so 25 times 0.16, that times that is actually just 4. So 7 divided by 4 pi, and you get 0.557 meters per minute. That's the change of the height with respect to time. That's how fast the height is changing.